Okay, just continuing from the 2017 question 1, part D. The diagram below is repeated from the previous page. We've got all this. At one point, the stationary diaphragm has a uniform negative charge of this and is located in the middle of the slider. The mass is this and the width is 1 centimeter. The conducting plates are 3 centimeters apart. Find the maximum speed the diaphragm will have before it is stopped by the edge of the slider. Alright, this is where lots of people mess up. So, state any assumptions you make. They've already given you a clue on what to do. So this assumptions just means conservation of energy. So just saying EP equals EK. So all the electric potential energy is going to be converted to kinetic energy. Just stating that already gets you an achieve. So even if you have no idea what to do, just stating that you already get a third of the marks. Quite easy. So let's focus back on the question. So we know that EP, to find the velocity, we first need to find the what EP is, and then we can assume whatever we get for EP is going to be the kinetic energy, and then we just rearrange for velocity using the EK formula, and that will get us our maximum speed. So EP equals electric field strength times the charge times the distance. Now that is going to equal the electric field strength, which is all the way back up here, 2 times 10 to the 5, or 200,000. 2 times 10 to the 5, times the charge, which is here. I'm just going to change it to a positive because I want to get a positive result, because I can't square root a negative number. And then the distance. Now this is where people make mistakes. You have to read the question carefully. That gives you a clue. So, find the maximum speed the diaphragm will have before it is stopped by the edge of the slider. We actually have to know what the slider is. Now, we can't just chuck in 3 centimeters or 1 centimeter, because both of those aren't correct. So, I'm not worried about this here. Okay, that's irrelevant. I'm worried about this part here. Now, it says we're trying to find the velocity during when it's in the middle of the the diaphragm, until it reaches the edge of the slider. So this is the slider here. This box, that's the slider. They've even pointed it to us here. So pretend your diaphragm thingy starts in the middle. Starts here. Now the whole slider is 1 centimeter, which is 0.01 meters. So, if we want to find the distance, it's going to be half of this. So it's going to equal 0.05 meters. Okay, half of the 1 centimeter, or the 0. Sorry, that's actually really messy. I'm gonna write that better. So half of 0.01. Okay, so now we have the correct distance value, which is this here. So I'm going to put that in. 0.005, it's a very small number. If you put this into your calculator, you should get an answer if you've rounded it appropriately. 0.042 joules. So, we've now found the potential energy. So, using our conservation rule, we can just write EK equals EP. So, EK equals 0.042, which is just this here. Okay, so now, using our kinetic energy formula, EK equals half of mv squared. Now you can rearrange it. I already know how to rearrange it. I just memorize it. So V equals the square root of 2EK divided by m. So we're going to chuck in our values. 2 times 0.042 divided by the mass, which they should have given us. Yeah, it's right here. 5.8 times 10 to the 5. 5.8 times 10 to the 5. So that should equal 38.1 meters per second, rounded to 3 significant figures. Right, there's your excellence question to end it off. So for excellence, you needed to have the correct velocity, and you must, and correct assumption, which is literally just the EP equals EK. So that's just that. For merit, you have assumed the energy conservation, so you've got this, and a valid attempt at finding V. So somewhere around here, you might have just messed up, maybe especially with this part here. If you got the incorrect distance, but your working was all sort of neat, they might give you a merit. And then achieved, as I already said it, literally, yeah, just that. Pretty nice. Or you state energy conservation, no losses due to friction. I don't understand why you get all that when you can literally just write this, but yeah. So that's question 1 done. I will do question 2 another day. Sorry for not uploading in a while. Been very busy, but with 1 week to go until the exams, I'll try and pump out some tutorials. Cheers.